Hi everyone! In this course demo, I'm going to show you how to encapsulate a mutable field properly. We are going to create a class course with 3 private fields: code, title, and prerequisites. Code represents a unique identifier of a course, such as CMPT 101 and Math 114. The title is a short description of the course. For example, Object-Oriented Programming for CMPT 305. Prerequisites are stored in a set because we don't need to put the same course more than once as a prerequisite. We provide a simple constructor that takes code and title. This constructor allows client code to construct an instance of course with no prerequisites. We also create and assign an empty set as a prerequisite. We provide a second constructor that takes code, title, and prerequisites. This example demonstrates that a class can have multiple constructors. You also see that the statements in both constructors are very similar. In general, it's a good idea to avoid duplications in our code. So we are going to replace the duplicated statements with a call to the other constructor. A constructor can call another constructor using the this keyword. We pass the code, title, and an empty set to the second constructor, which then assigns the given values to the field. For testing and development, it's useful to override the toString method to return meaningful information about a course object. In this case, we return the course code and title. We also provide getter methods, getCode, getTitle, and getPrerequisites, where each returns the value of a specific field. We want to ensure that changing a course prerequisites must be done through the add prerequisite or remove prerequisite function. We don't want to allow random code to change the requirements of a course arbitrarily. Let's test the current version of the class to see if it works as expected. Similar to the earlier demo, we create a class called main to represent the client code. We declare a set of prerequisites and use it to instantiate a course CMPT 450. The program seems to work correctly. Let's add CMPT 250 to the prerequisites twice. Although we've used a set to manage course prerequisites, you see that the collection still includes both CMPT 250 objects. Is there something wrong with the implementation? The implementation of the add and remove prerequisite methods looks fine. It calls the contains method to see if the given course is in the collection before adding or removing it. Apparently, the contains method relies on the equals method to compare objects. Since we have not overridden the equals method in our class, the default behavior compares whether two object references point to the same entity, which is not the case because there are two distinct CMPT 250 objects. How do we solve this problem? We can change the implementation of the equals method to check if two courses have the same code. If yes, we can conclude that they are equal because a course code serves as a unique identifier. For a bit of performance optimization, we start by checking if the given argument is a reference to this object. If that's not the case, we examine the type of the given object. If the type matches, we typecast it into course and compare the code. But why does the program still produce incorrect output? You need to remember that when you override equals, you also need to override hash code. Recall that two equal objects must have the same hash code. This specification is used by hash-based data structures such as hash sets for performance optimization. Since course code is a unique identifier of a course, we can use it to generate hash code for each instance of course. Now, you see that the set doesn't contain any duplicate values. CMPT 450 has two prerequisites, CMPT 250 and 305. Let's modify our program to reflect this requirement. When you implement a class, you should encapsulate the fields carefully. You might think that it's enough to declare all fields private so that they are accessible only within the class. Unfortunately, this is not enough when a class member is mutable. Code and title are strings, and strings are immutable, so we don't have to worry about them. Prerequisites, however, is a hash set, and a hash set is a mutable object. Any code with a reference to the collection will be able to modify its contents directly. Without proper encapsulations, the main class can change the prerequisites of a course without using the add or remove prerequisite method. For example, after constructing a CMPT 450 object, the client program can add a new requirement to CMPT 450, such as English 101 arbitrarily. How can we encapsulate a mutable field properly? Let's review the class course. There are two places where the field prerequisites is accessed. First is when it's assigned a value in the constructor. Rather than assigning the given argument directly, we should make a defensive copy of it. For example, by using a copy constructor of hashset. The main function is no longer able to change the prerequisites of CMPT 450 freely. Another place we should modify is in the getter method. If getPrerequisites returns a reference to the set, which is a mutable object, any code receiving the reference from the getter method can modify the contents of the collection directly. To send a clear message to the client code that it shouldn't change the contents of the set, we can make getPrerequisites return an unmodifiable set. Any attempt to alter the contents of an unmodifiable collection will trigger an exception. All fields of the class course are now appropriately encapsulated. In summary, this demo shows how to encapsulate a mutable field properly. Declaring mutable fields as private is not enough. We must make a defensive copy of mutable objects to ensure that no client code will be able to change their values without going through the application programming interface provided by a class. In this example, we made a defensive copy of a set in the constructor and returned an unmodifiable set in the getter method. We didn't need to do the same for course code and title because these fields are strings, and strings are immutable objects.